Hello, Algebra 2 folks, and welcome to Special Functions Describing Graphs. So you need your notes, a pencil, and your foldable. You may even want a few colors. I have 6 different colors that I'm going to be showing on this graph, so it might be very beneficial if you have 6 colors to keep everything kind of organized. All right, so the first thing we're going to do is talk about the learning targets. I can determine where the local maximum and minimum values are on the graph. I can determine where a graph is increasing or decreasing and state the intervals. And I can find the x-intercepts and the y-intercepts of the graph. All right, so take out your foldable and cut them on the red line and fold over on the green line. And we will take a look at these 4 topics. The first topic that we're going to talk about is the x and y intercepts. And then we'll move on to increasing and decreasing. We'll talk about relative max and mins, and then we'll talk about zero-root solutions and x-intercepts. All right, so let's get started. The first thing we're going to talk about is the the x and y intercepts. So the x-intercept is the point in the graph where the graph crosses the x-axis. Okay, so those are always going to be in ordered pair form. Okay, so this is what I have in purple. Okay, remember we need ordered pairs. Okay, so what are the ordered pair where it crosses the x-intercept? Well, -3, 0, 1, 0, and 5, 0. Okay, so you want to make sure that you do ordered pairs. All right, the y-intercept, which I'm going to go back to red, is the point on the graph where the y value crosses the y-axis. Okay, yeah. So there it is. There's where it crosses the y-axis. Therefore, that's the y-intercept. Again, these need to be in ordered pair form. Okay. So in this case, it's 0, a number. Y-intercepts, if you recall, the y-intercepts are a number, a 0. Okay? So just remember those have to be in ordered pair form. Okay, so then we're going to talk about a function, whether it's increasing or decreasing, because that's what the outside of this flap says. So the function is increasing over an interval if the y value is increasing and the x value is increasing. Okay, so if you put yourself right here, what I always tell students is put your finger right here and then draw where you're going to go. Well, I'm going to go up. So if I'm going to go up, that must be an increasing function. So that's an increasing part of the function. Okay, so when I get to the tippy top and I have to move my finger along the graph from left to right, this part is not going to be increasing. This part I'm going down. So that's probably decreasing. Well, I get to this point right here and I move my finger over the graph and I'm going up. So that would be another increasing part of the graph. So increasing intervals or even decreasing intervals, you have to use the x values of the graph. So take out your handy dandy little foldable where we talked about domain and range and use the domain part because the domain are the x values. So if I closed the domain here, I would run into an arrow. That's negative infinity. When I close it on the left, or excuse me, on the right, I would run into -1. So this graph is increasing from negative infinity to -1. It's also increasing from 3, and then if you fold over on the right, it's going to run into this arrow. That arrow is going to mean infinity. So those are the 2 increasing values. Okay, using x values. If the function is decreasing on an interval where the y values are going down, but the x values are going up, then we have a decreasing function. So that part of the function is decreasing. So decreasing, okay, I'm going to put that over here. It's decreasing from what x value? Yep, -1 all the way to 3. Good. Okay, so increasing, the graph is going up from left to right. Decreasing, the graph is going down from left to right. All right, now we are going to talk about the maximum and minimum points. The maximum point is the y value of the highest point in a particular region. So the highest point, well, the highest point would be, well, okay, there is no point, that's the highest. It's going to infinity, but it's an actual point, okay? So if you can you find a high point along this region? Well, it's right there, okay? So the maximum value we would say is 4 when x equals -1. That is how we would write the max. The max is equal to 4. It's the y value when x is -1. Okay, so the minimum value. Well, what would the minimum value be? Well, the minimum value would be the y value at the lowest point. Okay, so the absolute lowest value of this graph would be -infinity, but the relative minimum would be a point right there that's kind of showing you relatively this would be the lowest point of the graph in this particular region. We would say the minimum value is equal to -4 when or at x equals 3. You can say when or at x equals 3. Okay, it doesn't matter to me which way you do that. Okay, now we should know that zeros, roots, solutions, and intercepts are all the same thing. They all mean the same. They're words that all equal each other. And they describe the x value of the graph whose corresponding y value is 0. So where is the y value 0? Well, at 5, 1, and -3. Okay, so those are the zeros, the roots, the solutions, or the intercepts of the graph. Okay, now with that, okay, we are going to now do a couple of examples where I do all of this for one graph. Okay, example number 1, intercepts, x-intercepts. Okay, so what are the x-intercepts of the graph? Okay, the x-intercepts of the graph are where they cross the x-axis. Well, here, 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 and also here. So ordered pairs, -3, 0, -1, 0, 1, 0, and 3, 0. Okay, now what are the y-intercepts? The y-intercepts are where it crosses the y-axis. It crosses the y-axis right here. That would be 0, 9, because it's the y-axis. Okay, x and y intercepts. Those are always using x values. Okay, so we talk about x values. So increasing intervals. Well, where is this increasing? If I stand right here, how do I get down here? Oh, that's a down. How do I get down there? I'm going down, decreasing. Okay, so from this value to here, how do I get there? Oh, I have to walk up. So this part is increasing. Okay? I get to here, and I have to walk down again. So that's a decreasing part of the graph. I get to here, and I walk up, I have to increase. So what are the increasing parts of the graph? Well, look at your domain, open up your domain little sheet and close the book. If you close it right here, you're going to run into 0. You close it right here, you're going to run into -2. We always read from left to right. So the increasing interval is -2 to 0. And also from +2 to infinity. Decreasing. Where am I decreasing? Okay, well, if I started right here, I would walk down this graph. Okay, so if I'm walking down, then this is a decreasing part, and so is this one. Okay, so what are the decreasing intervals? Well, if you close your domain, you'd run into an arrow, so -infinity until what x value? Well, that would be -2, and from 0 to 2. Okay, so we've got decreasing intervals, increasing intervals. Okay, so now we have to talk about the maximum and the minimums. So the maximum would be, where does the graph relatively hit the highest point? Well, the highest point would be right here. Okay, so let's do that in green so you can see that. That is the highest point. So the maximum is 9 when x is 0. Okay. Now that's a relative max because these max would actually keep going forever and ever and ever, and these would keep going forever and ever. And so the minimum is the lowest points of the graph, and there's actually 2 of them, one here and one there. So the minimums would be -15 when x is equal to -2, and also -15 when x is equal to +2. Okay, now what's the domain? This should be easy. On the left, I run into an arrow. On the right, I run into an arrow. So -infinity to infinity. Okay, range, lowest value, close up my booklet, and I'd run into -15 all the way to, oh, sorry about that, all the way to +infinity. Okay, now what are the roots, solutions, zeros, or intercepts of this function? Well, they are where the y value is 0. So come up here to your x-intercepts. -3, -1, 1, and 3. And you do not write the 0 parts. Okay, there's one example. Okay, let's do another example. X-intercepts, that would be 3, 0, and -1, 0. Where did they cross the y? 0, -3. Increasing intervals, well, if I stand here and I get down to here, I am decreasing. And then when I get to here and I go up, I'm increasing. So the increasing interval is your x values from 1. And then this is going to run, if I close the domain, I'll run into an arrow. So that's +infinity. Decreasing, same way, if I close the left side of the domain, I'll run into an arrow, so -infinity, and it decreases all the way to the x value of 1. There are no maximum points. The max goes to infinity, so there really isn't any max. The minimum is way down here at this point, and that minimum is -4 when what x is equal to 1. Okay, now if you use your foldable for your domain and range, you fold it on the left, you'll run into an arrow. You fold it on the right, you'll run into an arrow. That's -infinity to infinity. With the range, you fold it up from the bottom and you'll hit -4. You fold down the top, you'll run into an arrow, -4 to infinity. What are the zeros, solutions, roots, or intercepts of this function? Well, that would be 3 and -1. Everywhere it crosses the x-axis where the y value is 0. Okay, so that's all I have for you today. Good luck on your worksheet, and we will see you again tomorrow.